So for this question, let's assume the 2D view of everything. So if we take a 2D view, we'll get the image as this. This is what we will get. So now let's just say this is center of the sphere, center of sphere O, and this is the height of cone. So height of cone, instead of trying to know that, let's just try to see this. So base of the cone or its diameter we can find. This is R, this is R, this is R. Radius, let's just say this is theta. Then we will get everything in terms of theta. So now that is theta and this is R. So this is theta by 2 and we get base. So now capital R, sorry, this is instead of smaller it's capital R, and let's just say R is a radius of this base of cone. Now R will be equal to capital R into that's just sine theta by 2. So sine theta by 2. Now height will be equal to radius plus, because from here till here it's radius only, radius plus this, radius plus R cos theta by 2, or we can simply say this as R sine alpha. Let's just say this is alpha, then this will become R into 1 plus cos alpha. Now we got everything in terms of capital R and alpha. And next thing what we can do is we are asked to find the dimensions such that volume of the cone is largest. So volume of cone is simply 1 by 3 pi r square, small r square h. So that is simply 1 by 3 into pi into r square only, capital R square. Sin alpha is simply sin square alpha here, and the other thing is R into 1 plus cos alpha. So this will get as 1 by 3 into pi into r cube. This will be a constant, and then remaining part will be sin square alpha, can be written as 1 minus cos square alpha. Then we get 1 minus cos square alpha or minus cos cube alpha plus cos alpha. So this is a function we'll get in terms of cos alpha. So now we know that this should be maximum. We need to find a condition when this is maximum. So that just becomes, if we find out, and we also know that volume of a sphere is equal to 4 by 3 pi r cube. This thing put aside, that is equal to, so if we say this is equal to some capital V naught, let's say, then this above volume of cone will become V naught by 4 into 1 minus cos square alpha minus cos cube alpha plus cos alpha. Now this thing must be equal to, in order for this to be maximum, we know that V dash of alpha is equal to 0. That implies V naught by 4 is common. So minus 2 into cos alpha into plus sin alpha. We get into minus sin alpha. Minus here cancel, total will come plus. Similarly here plus 3 cos square alpha into sin alpha minus sin alpha. This whole thing is equal to 0. So that will imply sin alpha we can take common. Sin alpha into this will be 2 cos alpha plus 3 cos square alpha minus 1 is equal to 0. So this will become sin alpha into 3 something square is 2 into something minus 1 equal to 0. So we can take sin alpha common into 3 cos alpha plus 1 into cos alpha. Okay, this will become minus, this will become cos alpha plus 1 is equal to 0. So finally we get 3 values, that is cos alpha is equal to 1 by 3, cos alpha equal to minus 1, and sin alpha equal to 0. Sin alpha equal to 0 means, okay, these both are similar cases, which implies that alpha equal to some, here alpha equal to 0 and here alpha equal to pi. We know that alpha which is equal to theta by 2 can't be pi, it can't be as big as pi. So we get this alpha equal to 0 and alpha equal to pi, both cases get cancelled. So the only thing we are left with is 1 by 3. So finally if we put cos alpha equal to 1 by 3, we get volume of cone. I just forgot. Volume of cone will be equal to V0 by 4 into this is 1 minus cos square alpha is 1 by 9 minus cos cube alpha is 1 by 27 plus cos alpha is simply 1 by 3. So this will become V0 by 4 into 4 by 3 minus 4 by 27. So this we can get 4, we can remove, this will become by 27 into 8. So we got that volume of cone is equal to 8 by 27 times volume of sphere in which it is inscribed. This is what we are supposed to show. And how do we get? We just showed that to get minima or maxima, we should, that f dash of x should be equal to 0. By putting this, we reach the required condition.